Hello students, welcome to the second video of the chapter Conic Sections. In the previous video, we had learned how the basic shapes of the conic sections are formed from a double cone, right? So we had learned about how to make different cuts in a double cone to get a particular conic section. In this video, we will try to derive, see the whole derivation of ellipse and hyperbola and parabola is not possible in a small video. That takes one video per set itself. But here we will try to learn the equations of these basic four conic sections. And what is the concept behind those equations? So every conic section is defined according to its basic characteristics, right? Starting with the circle, the definition of a circle is a set of all points in a plane that are equidistant from a fixed point in the plane, right? The fixed point is called the center of the circle, and the distance from the center of a point to the point on the circle is called the radius of the circle. Now see, what does the definition say? We have a fixed point. When we talk about the fixed point, that means it is a point which is given in the definition itself. It will be a known point, right? So let us assume that the known point is h comma k. It is a fixed point whose coordinates will be known to us. It is a point in a two-dimensional plane. When we are talking about constructing a conic section, see, all of them are a kind of curve. All of them are curves. Every line or every curve has general infinite points on it, right? Like if you have a line, it has infinite points lying on it. So the general point, any general point on a line or on a curve is given as like P, which is x comma y. This is a general point. Here it is given. See, this circle itself is made up of infinite points. And if we are talking about finding a relationship between the fixed point and any unknown point, here we are trying to do that. So the fixed point's coordinates are taken as h comma k. Any general point on this whole curve can be taken as x comma y. Now, whatever equation we will form here, it will actually satisfy all those points which are lying on this circle, right? So what is the definition? How do we define a circle? It is a set of points in the plane, right, which are equidistant from a fixed point. Now let us start from basic. If we have a point here, right, let's say at a fixed distance, let that distance be 3 centimeters, right? Now what you can do is I'm just doing it with a rough hand. So try to understand, like I am marking random points at a distance of 3 centimeters from this given point. These are few points. There will be infinite, right? A set of points in a plane that are equidistant from a fixed point. Now this is a fixed point, and all these points, I have just drawn them randomly. Let's say this is a 3 centimeter with a few points which are at a distance of 3 centimeter. Now you collect them, combine them, you will get a circle, right? So the concept here is you have to take a fixed point in a two-dimensional plane, right? And after that, take a fixed distance from that point and then mark few points on the plane. When you join them, you get a curve. And that curve in this case is called a circle, right? Now, what are the things given to us? This fixed point will be given to us. Let this be C, center is C. Any random point on this curve can be taken as x comma y, right? This is a very small equation, so we can derive it here. Right? Now the definition says that all the points are equidistant from this given fixed point, right? So we know the distance formula. What we have to do is we have to keep the distance same. The distance between any general point x comma y and this fixed point h comma k is a fixed unit which is called the radius, right? So we can write here square root of x minus h whole square plus y minus k whole square is equal to r. This is a distance formula between 2 points. You had learned this in class 10. The distance between these 2 points is called radius. This is called the radius of the circle. Right? I have just applied distance formula from this fixed point to general point in the circle. Now solving this, we can take the square on both the sides. X minus h whole square plus y minus k whole square. So this is the equation of a circle whose center is point h comma k and the radius is r, right? This is the equation of a circle. Now we can have a particular equation in case this center is at the origin. What happens if we make a circle like this, right? If the center is at origin, in that case, this fixed point h comma k becomes 0, 0. Now replace 0, 0 in this equation, right? You will get an equation of the form x minus c. This becomes x minus 0 square, y minus 0 square, and this is r square. So in case of the center being origin, we get an equation. This, right? So this is an equation. This is the general equation of a circle. This is a particular equation in which the center is origin. Now let's come to the next conic section, which is parabola. Right? How do we define a parabola? See, if you try to understand, the basis of the equation is given in the definition itself, right? A parabola is the set of points in a plane that are equidistant from a fixed line and a fixed point, not on that line in the plane. So here the figure is given. Let me explain you how can we draw it, then we remember it better. See this, let this be a fixed line, right? Let here be any point P, or you can say F, right? This is F and this is a line L. We have to take the points in a plane that are equidistant from a fixed line and a fixed point. This is a fixed line. This is a fixed point. We have to locate such points which are equidistant from both the things. So very first thing will be if we draw a line joining these this line and this point. The midpoint of this will be the first point, right? Will be the first point which is equidistant from both line as well as the focus, this point. Now start marking such points. Let's say if I have a point here, this distance will be equal to this distance. This distance is equal to, similarly, we join few points here. Points which are equidistant. These are the points which are equidistant from this line as well as this point. Now, if we connect such points, what do we get? We get a parabola, right? So this is the definition. You can make the figure. First, you have to remember the definition so that you know the concept. So here we have a fixed line. This fixed line is called the directrix. The directrix, and this fixed point is called the focus of the parabola, right? these distances are equal. Like if we have taken these 3 points, P1F, from F to P1 and from B1 to P1, these distances are same. This distance and this distance is equal to this is equal to this. So if we connect all the similar points, there are infinite points, right? Then we can get this figure which is called parabola, right? Now deriving the equation of this parabola is a bit difficult here in this small video, but let me tell you, if there are 4 different kind of parabolas that we can form here. So the basic equation like this one is, how you can remember it? This parabola is symmetric about x-axis, positive direction of x-axis, right? So the here equation becomes y square is equal to 4ax, right? Y square is equal to 4ax, where a is nothing but this. This a is the vertex, so coordinate of the focus. See the vertex here in ideal condition, what we are learning here, in ideal condition, this vertex is taken out to be origin. The distance here, see we had just learned that every point on this parabola is equidistant from the line. So if we take this as 0, 0, this point, 0, 0, this distance is a on x-axis. So this point will be minus a, right? This is x-axis. This is x-axis and this is vertex. If we are a units to the right for the focus, then we are a units to the left for directrix. So this is equation of directrix here becomes, what is this? This is a line parallel to y-axis. So x is equal to minus a, or x plus a is equal to 0 is the equation of directrix. This is the equation of the parabola, right? And if we have a parabola like this, it is facing towards, this is like y-axis, this is directrix here. This is 0, 0. If we have parabola facing towards negative direction of x-axis, the equation modifies to be y square is equal to minus 4ax, right? We can have it this way also. A parabola can be symmetric about y-axis, positive direction of y-axis. In this case, how you can remember this is, if your positive x direction is in the middle of the parabola, then it is the linear part. Y square is equal to x is there and positive x. So this is positive. Positive x is the axis. Here, negative x axis is the axis of parabola. In this case, when the axis of parabola is positive direction of y-axis, equation becomes, right? And here, if it is this way, negative direction of y-axis, the equation becomes x square is equal to minus 4ay. In all these equations, xy is a general point which lies on the parabola, and a is the coordinate of focus. Whether it is on x-axis or y-axis, a represents the coordinate of the focus, right? Next we have ellipse. Now what is the basic definition of an ellipse? An ellipse is the set of all points in a plane, the sum of whose distances from 2 fixed points in the plane is a constant, right? Let's say we have 2 fixed points. Let me explain you how we can construct this ellipse. These are 2 fixed points. I'm combining them, joining them to this. Let this be F1, this be F2. Now it is a set of points in which the sum of whose distances, let's say we have a point here, right? Now the distance, let this be point P. This is PF1, this is PF2, right? PF1 plus PF2, let's say we have a distance. Distance is a constant, like sum of distances. Sum of distances is 10. Like PF1 plus PF2 is 10. Let's say we have 3 here and 7 here. Sum is 10. Let me take some point here. This is 4. This is 6. Right? This is 5. This is 5. Right? Now here, if I go there, now this is 6 and this is 4. This is 7 and this is 3. If I join all such points, I will be getting a figure like this. Right? This is an ellipse. I'm sorry for just not drawing it properly, but this is the kind of figure that you will get here. The concept is take two fixed points. These are called foci. Foci, right? Now, if you take any point, take the sum of the distances from this F1, these two foci, F1 and F2, take any point. Then take some other point. Let's say this distance is 10. Now take all those points whose distances from these two fixed points sum up to 10. When we join these 2 points, we get a curve called ellipse. Earlier, we had learned how do we get it when we cut one cone of double cone in a tilted way. So the top view here becomes ellipse. So it is an elongated circle, right? Now, if we assume ideally that we make this, this is the horizontal axis, this is the vertical axis. Let us say if we assume that these two axes are intersecting each other at origin, right? If we consider the center as origin, in that case, this is origin. If this distance is, let's say, a comma 0, this is minus a comma 0, because they will be equidistant. This figure is symmetrical. Now this distance on the vertical axis is 0 comma b. This becomes 0 comma minus b. Now see here, the total length of the major axis, this is called, the longer one is called major axis. The smaller one is called minor axis. The length of major axis is A from here and A from here. So this major axis is 2A, right? And the minor axis, the length of minor axis is B here and B here. That is 2B, right? So these are the lengths of the axis here. Now what we have to learn here is, what is the equation? Equation of deriving the whole equation here is bit not possible right now. So I will tell you how to write equation. Equation of this ellipse is x square by a square plus y square by b square is equal to 1. Right? What does a represent here? A is the length of major axis, right? And B is the length of minor axis, right? Now what happens if we tilt this ellipse like this, right? In that case, now the major axis has been shifted to y and the minor axis has been shifted to x. So nothing is there, but the thing is we always consider A to be the length of major axis. Now what happens here? We can write x square by b square plus y square by a square, right? When we are writing the equation, we have to assume that a is always greater than b. So this can tell you that here the ellipse will be of this type, elongated on y-axis. So these are the two equations of two different kind of ellipse that we can have, either on x-axis or y-axis. The last one is the hyperbola. This is nothing but you can say the same concept as an ellipse, But here we are taking the points, the difference of whose distances from two given fixed points is a constant, right? You can see here, this is F1 and this is F2. These are two foci, right? These are two foci. Now, if we take P1 here, P1, P1, F1, here the next distance is from this point P1 has a distance P1, F1 from this and P1, F2 from the second foci. What is the difference here? This is P1, F2 minus P1, F1. This is the difference of these two distances. Now, if we take a similar point P2, here it will be P2, F2 minus P2, F1. That means the distance, the difference of the distances from these 2 points, like let's say this is, you can say this is 15 and this is 5. The difference is 10, right? Let's say this is 14 and this is 4. Again, the difference is 10. So the difference has to be constant from these two given fixed points. In that case, the figure that we derive is hyperbola. It is of this kind. Now see, here we have this axis. This is called transverse axis. Transverse axis. And the axis which is generally not seen here in the questions, this is called conjugate axis. Conjugate axis. If we consider this point to be origin, this to be origin. Now you can see that let this be vertex. Let this be the vertex of this side and this be the vertex of this side. Here the foci will be like F2 here and F1 here, right? So the equation of hyperbola when we have major axis like transverse axis or x-axis is x square by a square minus y square by b square is equal to 1, right? This can also happen that we have this transverse axis on y-axis and conjugate axis on x-axis, right? So in this case also the equation gets modified, like we have, since here the major axis goes on x, so we take a here. Otherwise, we can have y square by a square minus x square by b square is equal to 1. Right, these are the basic equations that we have discussed here. The derivation of every conic section can be done, but that requires one class for every conic section, which is not possible here. If you like watching this video and you want to continue classes with me, do let me know through Urban Pro. If you like this video, please do comment and write what you want to see next in the video. Thank you so much.